Welcome to our video on Piranha Solution. Today, we'll explore a highly corrosive mixture of sulfuric acid and hydrogen peroxide, known for its extreme nature. We'll cover its chemical properties, usage, safety, historical relevance, and impact in lab settings. Before we dive in, it's crucial to emphasize the dangers of Piranha Solution. Never attempt to make it outside of controlled lab settings. Let's start with the chemical composition. Piranha Solution is typically made by mixing sulfuric acid and hydrogen peroxide in a ratio of 3:1. This mixture undergoes oxidation reactions that create a highly reactive environment. As we discuss the reaction mechanism, you'll see how this solution generates intense heat, making it exothermic and even causing vaporization. We'll illustrate these reactions with animations to show the molecular interactions. Now, let's take a look at the history and discovery of Piranha Solution. It was first used for specific cleaning purposes, and over time, it evolved into a staple in laboratory settings. We'll also cover some famous incidents involving Piranha Solution to highlight its dangers and the lessons learned from those experiences. Moving on to applications in modern labs, Piranha Solution is primarily used for cleaning lab glassware, effectively removing organic residues. It's also utilized in industries like microelectronics and high-tech fields. We'll explore research areas where Piranha Solution plays a critical role, particularly in preparing materials for nanotechnology. Safety and handling are paramount when dealing with Piranha Solution. We'll discuss the risks associated with its use, including the potential for explosive decomposition and its corrosiveness. Proper personal protective equipment, such as lab coats, goggles, and gloves, is essential. We'll explain how labs create standard operating procedures specifically for Piranha Solution, detailing storage, mixing procedures, and emergency protocols. In case of exposure, we'll cover first aid measures for burns or inhalation, and we may feature interviews with lab professionals who can share their experiences. Next, we'll address the environmental impact and disposal of Piranha Solution. It requires careful neutralization before disposal to prevent environmental harm. We'll outline the steps for neutralizing the solution and the chemicals involved in making it safe. Additionally, we'll briefly mention any eco-friendly alternatives being developed or used in labs to minimize environmental impact. We'll also discuss ethical and legal considerations surrounding Piranha Solution. This includes regulations regarding who can purchase and handle these chemicals, as well as the ethical implications of using such hazardous materials, especially in educational settings. In our real-world stories and anecdotes segment, we'll share personal accounts from scientists and lab technicians who have experience with Piranha Solution. We'll present case studies of lab accidents involving this solution, detailing the causes, outcomes, and lessons learned. We may invite lab professionals to share their first-hand experiences as well. As we wrap up, we'll recap the key points covered in this video: the chemistry, applications, safety, and environmental considerations of Piranha Solution. It's essential to emphasize the importance of safe and responsible handling of hazardous chemicals in scientific practice. We encourage you to ask questions in the comments and remind you of the dangers of attempting any experiments at home. Finally, we'll include a Q&A segment where we address potential viewer questions about Piranha Solution, its uses, or its properties. Thank you for joining us on this informative journey into the world of Piranha Solution.